go ahead.
There should be a button at the bottom, and if you just press that, it will turn it on.
Okay, it's working now. Thank you. It's working now. Are you all here? Yes. Thank you. So you can go ahead.
Okay. And by the way, junior just means 11th grade, and then sophomore just means 10th grade. So most of us here are just 10th and 11th graders, and we're excited to share with you guys. But we can let the other members present too.
I'm Mila.
Hello, my name is Natra. I am an 11th grader at the Illinois Mathematics and Science Academy, and I'm currently the head of World of Engineering chapter at Society of Women Engineers.
Hi, and my name is Alyssa, and I'm also an 11th grader.
Sorry to cut in. Please, she means that she's been SS1. In Nigeria, 11th grade is SS1. So you can go ahead. Thank you.
Yeah, thank you for clarifying.
Okay, so today we're going to be talking about Society of Women Engineers at our school, the Illinois Math and Science Academy. And then we're going to be talking about computer science and artificial intelligence. What are they and how they impact our future? And then we'll also be learning the basics of HTML, which is a web developer. And then we will talk about further resources and more opportunities for you guys to continue learning after today.
Yeah, definitely. So a little bit about us. We started talking about science and everything. And let me know if you guys can't hear me because my microphone is being a little bit tricky. But so as Himani said, we're from Illinois Math and Science Academy. And so we take probably more science classes and math classes than a normal high school in the US would. And we are a collection of students that come from around Illinois, which is our state. And we are a very collaborative school academically and also outside of school. So that can look like research or clubs like SWE. So SWE is basically an organization that focuses on kind of raising awareness and providing opportunities for women, identifying individuals and STEM, and really anyone. But something important to point out that many people may not know is that most STEM fields are kind of dominated by male identifying individuals instead of female, which means that there are more male identifying individuals in STEM.
Maya, I think we're losing you a bit on network. We're losing you a bit on network. So I don't know if you can just go a little slower and you can increase your volume.
Okay, of course. I'm so sorry.
I think it's just like fading a little bit out, just like speak louder, I guess. Maybe that might help.
I'm gonna also move it closer.
Yeah.
So another example of this issue of discrimination in the STEM fields is that salaries for men are on average $15,000 higher per year than a woman with the same skills for the same company and job. So
Sorry, Maya. Maya, please, I just want to summarize what you said a little bit to them. So she's talking about the skills of engineering and the kind of salary they can earn, right? Am I right? Am I
yes,
correct? Okay, she said that they can earn like $10,000. That's about 10 million if you practice some of these types of engineering. Please go ahead. Thank you.
yeah. So there's many different types of engineering. I won't list them all, but you can see them on the left of the slide. So some main types are aerospace, which studies how molecules interact with each other in fluids at different temperatures. And then there's also biomedical, which focuses a lot on the human body and how to make improvements in the health field. So if you've ever heard of maybe a robotic heart valve, biomedical engineers help develop things like that. So today we're going to be talking about computer science, which we'll learn a little bit more about in a second. But just before we move on, there's a couple of events that SWE has hosted at IMSA, in-person events. And so an example of architectural engineering that we provided for our community was a little contest to see who or what group of people could build the highest tower with spaghetti strips and marshmallows, which you can see in the picture below.
So now we're going to move on to talking about CS. Actually, can everyone hear me before I start off? Just to make sure.
And just before we start too, is there anyone who has like an idea or wants to share what they think computer science is in their own words? Before we kind of just talk about our definition.
You can, even if just, yeah, even if you have a bit of an idea, just go ahead.
Computer is a set of programs which are some set of computer programming or bringing together of different kinds of computers on particular segment of the brain is not anything.
Sorry, did you hear him?
Sorry, I had a bit of trouble hearing him.
Okay, should it repeat itself? Okay.
Computer is a set of programs which we can really join together to form something usable for it that might really help the world at large. Thank you.
Yeah, that's pretty close. Like computer science, you mentioned it's about computers. And you talked about using computers to solve problems. That is a spot on definition of what computer science is. And so computer science is the study of computers. So computer science focuses on algorithms. And so if you don't know what algorithms are, it's basically almost like a recipe of steps. So there's algorithms to make, let's say, a soup. So you put in ingredients, those are kind of steps. And you have to chop up ingredients, you have to mix ingredients. So those are kind of steps that make up an algorithm to make a soup. Just like that, there's steps that we can put into computers to tell it to do certain things. So that's kind of what algorithms are in the scope of computer science. Processes are kind of similar to algorithms, but they're really important to understand how computers do what they do. So if we want to processes are really important to understand how computers do calculations, such as like 1 times 2, or even like some crazy numbers like 1,576 times 2,783 or something like that. It's really important to understand how computers do it. So there's different processes that it uses. Principles and design kind of go together. When you tell a computer to do something through an algorithm, there are often different ways and different principles. Like basically those are rules that tell people how you should organize, how to tell a computer what to do. So instead of saying there's certain ways that you can tell a computer what to do, you can't just tell a computer what to do anyway. So there's certain restrictions, which are principles, and then designs of computers kind of also focus on the hardware behind computers. So any electronics that a computer uses, that's kind of part of a computer's design, as well as the software in a computer, which is the code that allows a computer to use the hardware to do certain things. So there's a question here. So how do we use computers to solve problems? Anybody want to answer that? Anybody have an idea?
Solve problems. He said through coding, but who else can answer? How do you use computers to solve problems?
Like directing it to the industrial parts, like helping the industries to solve like a critical problem, like maybe the use of an AI can really help to solve that thing.
Did you hear him?
Yeah. Those are definitely like great ideas. Like you can use computers to solve physical problems in the world. Even though computers don't really seem that physical when you're talking about software, you can create, like, let's just say an app that allows you to track certain things that allow you to take data and help solve like issues. For example, let's say roads in a community are really bad. You can kind of make an app that allows a phone to sense when there's a pothole and alert the nearby government to say, there's a pothole here, you need to fix it. Something like that, that can, even though it seems really simple, can solve a lot and make the roads really better in the community. And so basically, to be able to do that, to be able to solve problems using computers, we need to be able to communicate them. And does anybody know how we communicate with computers?
Probably by giving it prompts. I don't know.
Yeah, that's a good idea. It's pretty much what we do too. It's called code, and code is basically a language to talk to computers. So computers, they often do calculations in ones and zeros, but we can't understand ones and zeros. They don't make sense to us. So we need a way to be able to we can't just speak English to a computer either. So there needs to be a way for us to code. There needs to be a language that's kind of like a between of actual an actual language like English or and ones and zeros. So this is called code. There's different languages that you can use. There's C++, which is basically a language. There's also Python, Java. These are all languages that some coders use, computer scientists use to talk to computers. And you can also see CS everywhere, even on the laptops right now. The Zoom meeting that we're running, it uses CS. I mean, it's been designed through CS, and the way that we're able to share screens is through CS, because we're able to share information from here in the United States all the way to Nigeria. which is really cool, and it allows us to do some really awesome things. And then, so anybody can be a computer scientist, but what are some skills that are really important to be a computer scientist? Well, there's a few. There's problem solving. So to be able to be a computer scientist, you need to be able to look at a problem, understand that it is a problem, and then break the problem down into smaller components, right? And that's really, and then understand how to address those smaller components in code. So that's a really important part. You also need to be really creative. You need to be able to look at a problem and think about a new approach to solving a certain problem. And that's a really important part of being a computer scientist too. And finally, collaboration. You need to be able to work in a group, a team, to be able to do anything that you want with a computer. If you want to build an application or an app, you're most likely going to be working in a team. So you need to be able to collaborate with people. Does anybody have any questions so far, or or does this make sense? All right, moving on. What is AI? So AI is kind of a thing in computer science. So AI stands for artificial intelligence. Now, what is artificial intelligence? Basically, we're making computers think like us. So let's say I want to tell you to recognize a bird in an image to the right here. Everybody can obviously say, oh yeah, there's a bird right here, but computers can't say that. So AI is used to help allow computers to be able to think and also say, oh yeah, there's a bird in the image right there. And so why is AI important? So AI is really important because it provides a more productive and efficient way of solving problems. So in this image to the right, if you were to ask a regular computer with no AI to recognize a bird, it'll only be able to recognize one specific bird. So if you ask it to recognize a bird from another species, or let's say the bird was in a different location, it wouldn't be able to do that. So that's why we need AI to be able to recognize all birds, because it recognizes patterns just like us when we think. And AI allows for more automation, because AI can replace jobs that were typically really redundant and that could be replaced, that humans had to do, because now it's more efficient and it allows us to produce more and be able to do more accurately. And what can AI do? So AI can recognize speech. For example, as you can see, the captions in this Zoom meeting are generated by AI. It's able to recognize the words that I'm speaking and write them out for you. So that's speech recognition. Image recognition is kind of the idea that I talked about earlier. As you can see, you can recognize that bird in the image. It can recognize the bird in the image that is to the top. It can also play games. I'm not sure if you've heard about this, but AI is really good at playing chess, for example. It can even beat professionals because it's so good at thinking and figuring out the optimal algorithm for something. And then it's also really good at identifying patterns. As you can see in our bird example earlier, it was able to recognize the pattern of a bird in an image. And it realized that all birds have similar features. For example, a beak, and they're all shaped in a similar sort of way. And then it can also diagnose patients. So if you're going to an MRI scan, or if you're getting something in your body scanned at a hospital, you need to be able to understand and look at that image and understand what is happening. So AI can look at these images and understand if there are any problems, for example, if you have a broken bone, or if you have like a tumor or anything like that. There's also self-driving cars, which are able to use AI to understand where pedestrians are so they don't bump into them, stuff like that. Can you guys think of anything else you might be able to use AI for? Anybody want to think about that?
Okay, we can use AI to stop cyber crimes.
Sorry, I couldn't hear that. Something about friends?
Okay, he said we can use AI to stop cybercrime.
Yeah, that is a good one. That's a really good one. I like that idea. Yeah, you can use AI to understand patterns in where what cyber criminals do, where they attack, and help. And I also like what the professor said. AI can be used to diagnose diseases. I agree. If you have, for example, a scan, you want to look at it and see. You can kind of notice patterns, and also when people are walking, if you have issues with your legs or kind of tremors, you can help if you have like phone in a pocket, you can kind of see those tremors using how it rotates and moves the phone itself. And you can use an AI algorithm to help them realize that, oh, you have this sort of disease. So I think all those are really good ideas. You guys really got the hang of this. Moving on, forecast weather. That's also a good one. AI is actually used to forecast weather. Anytime you hear weather forecasts, they're all predicted by AI and patterns that we've observed before. I think that's a really good idea. Yeah. Okay. And then environmental studies and pollutant research. That's also a good one. Yeah. You can kind of use AI to predict where pollution is going to be, predictive analysis, all good ones. Good job. Moving on. Okay. So when we're talking about AI, there's a lot of different terms that can be confused with each other. For example, AI versus machine learning and deep learning. Now, they often are all very used and exchanged in conversation, but there are actually differences between each of these terms. So AI, we've already talked about this. Does anybody want to answer what AI is again? Remind me, I might have forgotten. So anybody want to take what AI is?
AI is called artificial intelligence.
Could you repeat that? I'm sorry, I couldn't hear. My microphone's really bad.
And AI is called artificial intelligence.
Yep, that's definitely correct. So artificial intelligence, yeah. And I also like what the professor said in the chat, making computers do human tasks. Artificial intelligence, those are all good definitions. Giving computers commands to do human jobs. Yep, they're all very good definitions. Now, machine learning is basically a type of AI that allows AIs to automatically adapt to new situations. So basically, there are certain types of AI that can only be used for one thing. They can only be used to recognize birds, for example, going back to our previous example. But in machine learning, we can tell it to recognize birds, we could tell it to recognize any type of animal, and it will be able to. So instead of when you show that same AI a picture of a turtle, it'll be able to understand that, oh, that's not a bird, that's a turtle. So machine learning will allow AIs to be able to do that. And then there's also deep learning. So deep learning is a type of machine learning, which basically uses multiple algorithms. So as you can see, basically, if we have a picture, we run it through an algorithm, which is basically a recipe of steps. Then we run it through another algorithm and another algorithm. As you can see in this bottom right image, like this bottom image, you can see that we have multiple inputs and it goes through this crazy network and then it goes to an output. So yeah, so those are the different types that you might hear in a day-to-day conversation, but now you're an expert. So now you can say, actually, AI is actually different from machine learning and deep learning. So AI using, yeah, so AI can obviously be used to replace a lot of like very mundane human tasks that allow us to do stuff more quickly and efficiently. So now we're going to show you a quick demo of what AI really looks like.
Oh, Sam, I'm gonna type it, or yeah, I'm gonna share my
Yeah,
screen.
Okay.
I'm sharing right now, so yeah.
You should be able to
Okay.
share your screen.
Okay. Oh. Just give me 1 second.
Thank you so much for that summary. It was quite informative. I'm sure we all learned so much, right? Can you give a round of applause? Thank you.
Okay, actually, it's not going to let me share because my computer won't allow me to. So, Hamani, can you
Yeah.
please pull it up, and then I'll just run like the thing you could type it in.
Mhm.
That's on. Okay. So we're going to give a few prompts. So this is ChatGPT. It's just one of many AI websites where you can give the AI commands. So let's type in, what is your favorite color? So the AI is going to give us is not going to give us an answer because it is not human. The AI will give us something that's more analytical. So this says, I don't have personal preferences, as I'm just a computer program here to assist you. Is there anything specific you'd like help with or to discuss? So the AI is prompting us to ask them an actual question instead of a personal one. So let's ask them to write something that normally would take us 20 minutes to write. So write a 500-word essay about high school. So in just seconds, the AI types out a bunch of paragraphs about high school, something that humans could not do in this short amount of time. Moni, you're gonna say something?
I was just gonna say, and it also is able to write correct grammatically because it's trained on a lot of data. And something cool about ChatGPT is that all of the questions that you ask it, or like if you like this response and say it's a good response, or if you say it's a bad response, it takes that input and it kind of changes and adapts for future responses too.
ChatGPT can also solve math problems very quickly, like Sam mentioned before. So let's type in 32 times 50. So it gives us the result very quickly. But if a human were to do it by hand, it'd probably take 2 to 3 minutes. But this only takes 1 second for the AI to type out. Does anybody want to type in chat of something we can give the AI to do?
Or if anyone who's sitting down wants to share something or something that they would like to explore. Or if you just have opinions or questions about this in general, that's okay too. Okay, someone in the
Maybe
chat
we can
wanted
ask it to- maybe we can ask it to tell us how the earth formed, because I don't really know how it formed. So I would like that.
So he wants to know how the earth was formed. That's the question.
Sorry, could you please repeat the comment?
Okay, he said he wants to know how the earth was formed. How the earth was formed.
Yes, that's a good question. Let's see what ChatGPT responds with. And the good thing about ChatGPT is that it's also able to give scientific information. So it's like an advanced Google search, but obviously sometimes it's inaccurate.
It also, instead of long paragraphs, most of the time, it gives you numbered lists or bullet points to make it easier to read. So one of these on here, it talks about the formation of the atmosphere. So you asked how the Earth was formed. There's many components to how the Earth was formed. So the AI recognizes this and gives us a list of how each aspect of the Earth was formed. So this one says, the Earth's atmosphere likely formed through the outgassing of volatile compounds trapped within the planetesimal material. So this is very academic. The AI gives a lot of big words. Usually, Hamani mentioned that it's grammatically correct most of the time. So we can really rely on AI to give us quick answers like this one.
And before we kind of move on, I'll show you something else that's kind of cool. We can also ask it to write as like or like write to a 5-year-old or something, so that you can kind of see like, instead of like the formal words, it's like super informal with like long time. So it's really cool how it can adapt. But I think we're gonna stop the demo here just for time's sake. But are there any questions about this tool? Okay. There is one question asked.
I can answer this.
Yeah.
The professor in the chat said, how do we address the ethical issues surrounding the use of artificial intelligence in higher education research, teaching, and learning? So at our school, a lot of students are involved in research. And when students at our school use AI to plagiarize papers or assignments, it's quickly addressed by a disciplinary infraction. So like it gets reported. But I don't know how to, like, I don't have a list of how to solve it. I just know that people need to learn how to write themselves and use AI for the good instead of stealing work from other people or from the AI bots. Did anybody else in the group want to add to that?
Yeah, I can talk a little bit more, I guess. I think another thing about it is with the like with ChatGPT, there's also a new technology tool called AI detectors, and they're easily able to detect AI writing because, as we can kind of see, it doesn't really sound like a human. Or like, I mean, this part I told it to write to like a 5-year-old, but like we can kind of see based on like the grammar and like how it writes, it doesn't really sound like a human, and you can't really find that voice through it. And for teachers, a lot of times they're able to kind of just see it because they know how students write. But the other thing is, there's also like AI detectors. If they're like in doubt, they can put it through, and then once if they do find out, then as like Alyssa said, there's like punishments and all of that. But are there any other questions before we move on?
One thing I also wanted to mention, can you guys hear me?
Mm-hmm.
Yeah. So one thing I also wanted to mention is that the use of AI is normally used for education and like learning from it. I mean, at first to see, like when I first saw ChatGPT and when I was first introduced to ChatGPT, I was amazed at how fast it could give it responses, almost like, as someone mentioned in the chat, chatbot magic. So something to utilize ChatGPT and other AI platforms is to learn from it and not let it replace the knowledge that we have, not let it replace the ethics that we have. That's definitely recently been a big problem in around the world since ChatGPT was released. And someone mentioned in the chat you could use AI to paraphrase so your work is not recognized as plagiarized work. Yes, of course, that as well, but definitely utilizing AI and these tools to help us to learn, but not to replace our learning is definitely important, because that brings into question that AI one day could be smarter than us and possibly take over the world. Those are many concerns that we have right now, but those are just to name a few.
Yeah, definitely. It's important to prioritize learning.
Oh, sorry. I was also just going to mention that AI is a collection of data and it can't assess bias in the way that humans can. So not only should we not be taking work that isn't ours, take everything it says with a grain of salt, because it may not be 100% accurate.
Yeah, definitely. It also draws from like inaccurate sources sometimes. If no one else has questions, I think we're running a little short on time, so we'll just move on to the next topic.
So, I saw the question in the chat, and we'll definitely make sure to address it before we are finished. But I wanted to shift the focus to robotics and the future of it. So, with the discussion of AI, CS, and machine learning, I wanted to focus on the hardware side and less more of the software side. So, in a computer, without the actual hardware side, which is basically the physical components of it, you will not be able to have a computer. But if you don't have the software side, it'll just be a box of like just mechanical parts that you cannot utilize. So utilizing both these components and making them into something useful for us to do is called a robot. So what do you guys have any definitions of a robot? It could be simple, but anyone want to speak it out or tell me in the chat?
And it doesn't have to be correct, just like an idea of what you think it is, so that will like clarify it later too. If
Okay,
not,
yeah.
that's completely fine.
Yeah, no worries, no worries. So a robot, there's many different types of robot, but just the general definition is an autonomous machine, which means basically pre-programmed. So we put the code into it, and it's capable of performing while sensing the things around it, while sensing its environment, and carrying out computations to complete the task we assign it. In some cases, robots are used to accomplish what humans cannot. There are several kinds of robots, and these are just a few examples that that are pretty prominent and I wanted to spotlight. So, on the left-hand corner, you could see assembly. These robots are usually used in a warehouse, and they assist to speed up the process. For example, if you know Amazon, a retail company that provides packages to everyone's houses, is utilizes assembly robots to assist with packaging and speeding that up. A human, for example, in ChatGPT, we saw the AI could figure out something that we take 20 minutes, but it figured out less than 20 seconds. That's what the robot is also used to assist for, to package a box or to assist with anything in the warehouse. It could finish something or lift heavy objects in less time and complete it more efficiently than we do. That's definitely something important. And in the middle right here, we have humanoid robots, which are probably the most popular and, in my personal opinion, the most coolest. So the humanoid robots are basically creating robots that complete similar tasks and able to sense its environment like we do. In some cases, humanoid robots are made to also look like us. For example, Sophia is a robot created, and she's very known for looking, talking like us, and responding the same way we do. I have a few examples on the center of what Boston Dynamics, a company in Boston, created. And these robots are super flexible. They're able to lift so many things, and they're able to just do inhumane tasks, flip around 10 times in a second. They're able to run faster than we can normally. And that's what these robots are used for. They're in the future, they could help us replace some of the people in the workforces, but that's definitely a discussion going on. Rovers on the right-hand side are used in space exploration. For example, this rover on Mars by NASA was sent by NASA to identify and sample the grounds for us to learn more about Mars. Mars has a significantly lower pressure, and we can't go to Mars. So that's why we send robots to help us learn more and learn more about the information. So does anyone have any questions or any more like examples of robots that they think they know or find possibly?
Another example of robots are drones.
He said another example of robots are drones. Drones.
Oh, yes, of course. I know. I love drones. Drones are super cool, and they are robots. They are able to fly up, sense its environment, make sure some robots can avoid conflict. For example, if you were to throw something at the drone, sometimes it can move away if it's super smart. And drones are able to, sometimes they carry cameras for us to know what we look like from above. In the chat, let me pull up the chat. Okay, yeah, I can't see any questions. So, does anyone have any questions so far or anything to comment on? If not, I could just move on as well. There are thousands of kinds of robots, just to name a few. So we discuss some examples, drones, humanoid, assembly, and now let's dive into the actual components to robotics. Hardware, software are the two different sectors. However, there are many more. Hardware is the base of the bot, something I mentioned, almost like the mechanical side, something that you could see on the outside, and the mechanical and electrical components, which are like sensors, motors, power supply, the base, and the arm. So these are physical components, the ones that you could see, and ones that the robot uses to analyze data from its environment and surroundings. So with just hardware, a robot is technically like a box. It can't move around. It will just be stable, and we won't be able to ask it to perform tasks. That's basically asking something that's not alive, just to asking, like, for example, a watch to just move. Using software, these are the non-physical components. We mentioned computer science and AI. The software utilizes both of these components, and using the data that the mechanical side provided it, and it's a control system that enables the robot and gives it knowledge, tells it what to do, and this enables the robot to utilize the data and senses its surroundings. And the outcome in the end are several different types of robots. These are just to name a few. There are so many different disciplines for robotics. For example, robotics engineering is one, mechanical engineering is one, aerospace engineering if you want to build rovers for Mars. And I just wanted to provide an example of how students in high schools or elementary schools, students in the educational sector, how do they utilize robotics on a day-to-day basis? Lonnie, can you pull up Vex Robotics if possible? And then can you go to images first, actually? So right here are some examples that students use in games that a company called Vex Robotics provides. Through some of these pictures, you could see different kinds of mechanical and hardware components. Not every robot has to look the same, but these are just so many different types of what robots look like, and with the program that we provide, it can execute the tasks that we want it to do. So does anybody have any questions or anything to add on?
I have a question. I have a question. The question is there a preventive measure that we can really use to, make the AI not to have too much control of itself, so that people will just one day start reacting abnormal? That's the first question. For the second question, what good, like you say, we can use the AI for good and bad. So I would like if you can tell me the preventive measures that I can use to use the AI for good. Thank you.
Sorry, did you get his question?
Would you be able to repeat the question? I'm so sorry.
Okay, he said that he wants to know if there's any preventive measures to stop AI from being used in a bad way, because he said AI can be used for good and it can be used for bad. So what can you do to prevent the AI doing what we did not, losing control, humans losing control over the AI? What can we do to prevent that? Right? Yes, that's his question.
Yeah, I could definitely answer that. So AI and for example, even robotics, they're definitely becoming more prominent. And sometimes it does look like we're losing control. The more AI gets developed, the more ChatGPT gets developed, the more power it has, the more it can do and eventually replace us one day. Preventative measures, they could be setting rules and restrictions on a basis of, for example, plagiarism is quite common, as Alyssa and Hamani mentioned earlier. So utilizing AI and AI detectors to stop plagiarizing and detect plagiarism is definitely useful. With AI growing, it's only possible to limit the use of AI as well, because continuous development may cause a problem, and it may eventually cause like AI and robotics to overthrow us, for example. Does anyone else want to add on anything?
Yeah, so like, and there are different ways that AI can, the designers, the creators of AI, can also make sure that it's not used for the wrong things. For example, like any sort of classified intelligence, or like sort of anything that relates to weapons, on ChatGPT and a lot of all other general AIs, generative AIs are kind of not allowed to be responded to. Any sort of questions regarding those sort of intelligence or weapons questions are not allowed to be asked, and they will not get a response. And in addition, like in our school, there's also a lot of rules, for example, like to prevent like AI from being used by us to help finish our assignments, our writing assignments, like Himani and Alyssa talked about. And yeah, so there's a lot of things that also people who make AIs can do to make sure that it doesn't respond to certain sorts of questions and topics that may be dangerous to actually for it to give answers to.
I think we should move on to the next one, like the next slide. Yeah.
Yeah, we're running a little short on time, but I hope you guys learned a little bit about artificial intelligence and robotics. And for the next part of the section, we'll be learning about HTML, which stands for Hypertext Markup Language. It might seem a little bit fancy, but it's basically just like a web development programming language, or actually in this case, it's not necessarily a programming language, unlike other computer science languages, but it's a markup language, meaning that it's used mainly for web development. And today, HTML is widely used around the world, and it's like a building block to build all of those web pages, and it helps create the structure and layout of all of the pages that you might see. Like we opened ChatGPT, we opened the images on Google. And the main part of HTML revolves around tags. Like, I don't know if you can see my cursor, but every time you have like the left tag with like, it's like a left arrow, and then you have a right arrow, anything in between that is a tag. So like, for example, we see like the arrow P and then the arrow, which is a tag for paragraph. And that lets the computer know that you want to put a paragraph on the page, and it formats it similar to a paragraph. And with HTML, there are many different elements that you can add onto a web page. Like you can add text, images, links, and many more, and format them on your web pages. And the thing about HTML, and the reason it's widely used around the world, is because it's very beginner friendly and easy to understand, which makes it a great starting point to learn web development. And the reason it's super easy to understand is because it's very similar to English, except that you just have tags. Like, for example, usually computers learn and process information through binary numbers or zeros and ones, but whereas HTML revolves around these tags, and we use this language to convert these tags to the language that the computer that can understand, which is, I'll show you guys an example later to help you guys better understand it. But for example, this is a little bit of HTML code. And here the first tag is the doc type HTML. And this tag is just necessary to tell the computer that you're starting an HTML document. And after that tag, we have a body tag, which is telling the computer that we're defining the body. And the body is just everything on your web page. So everything that you see is going to be defined in the body. And for starters, I already have the first heading defined as H1. And another cool thing about HTML is this. As we can see, in between each tag, there's a starting tag, which is just the H1 tag, and everything in between the starting and ending tag. And as you can see, the main difference between both of these tags is the slash here. The forward slash in the ending tag tells us that it's an ending tag for the heading, so that everything between the starting and ending tag will be shown on the web page. So for example, if I write first heading or something, and if I press run, and here what the run button is doing is once I press run, it'll convert everything I have written into machine code that the computer can understand and process. And that's kind of what I was talking about earlier, as we talked about it a little bit before, but this code is just used as a language between us and the computer to kind of help it put as like a connection between both of the languages. And here, once I press run, we can see that the formatting kind of changes. But I know this is like a little bit of new information, and most of you have probably never seen this type of tags. So are there any quick questions before I move on to like a little bit more about the tags? If not, I'm going to write something else. And can someone tell me or predict what they think this will do? So as we kind of saw,
Is there
Oh, you
any
can go
way that artificial intelligence can override the human intelligence?
sorry, can you repeat the question?
Sorry, you asked us a question. Can you repeat your question?
Oh, my
Can you
question?
repeat that?
Yeah. I'll repeat my question. I was just saying, so we had the first heading defined as H1 with a starting tag, and then we have the closing tag. And then I did something similar, but instead of H1, I used H2. So are there any predictions on what this might do? So if it's the second heading, will So some prediction might be that the text would be bigger or smaller. So does anyone have any predictions? It's okay to be wrong. We're just guessing here.
Probably second heading. Since you have first heading there, maybe H2 may give us second heading.
Mm-hmm. Yeah, that's completely right. The second heading will, as you said, it's going to be like a second heading. I kind of gave it away with the writing too, but it's much smaller. And the cool thing about HTML is it can go up to 6 of this. So you can go all the way to H6 for 6. Oh, I think I accidentally deleted it, but you can go up till 6 headings. And right now, obviously, our text does not look super fun. It's plain and black. So the cool thing about HTML is there's many options you can use in order to style these. For example, the format you can use to style them is inside the starting tag, you have to write style equals, and then in quotation marks, you put the first part is what you want to change. For example, I can change the color, and then you put a colon, and then you specify what color you want to change it to. For example, I want to change the first heading to color blue. And now we can see that it changed. And using small style things like this, we can eventually we can build the page and make it look much more interesting. And another part that I kind of wanted to share with you guys today is lists. So I know in our slides we had a few bullet points, but another way you can do that using HTML is the li tag. So this li tag lets you put everything that you have inside it as a list. So it'll add like a bullet point. Are there any questions about what I have so far?
Yes, I have a question. Please, I want to find out what software do you use to keep in the HTML language? What software or what website?
Right now, I'm using W3 Schools, and this is just like an online compiler that converts, as I was talking about, the code into something that you can display. But usually you would write everything on your computer, and you can write it on a normal text editor like Notepad or like anything that you might have on your laptop. But we'll talk about this more later. But W3 Schools is like it's just a really cool website where you can learn a lot about any language that you want. And I'm just currently using their editor to convert this code into a sample display of how the website might look like.
Okay, thank you.
And I know we're running low on time, but before we leave, I want to also show kind of a few other things that you can do. So I know when we look at websites, usually everything's centered and it looks nice and pretty. So another kind of thing that we can use inside the headings is text align center. And what this, does anyone have any predictions on what this might do before I kind of explain what it will do?
Perhaps to put, I'm Brian, perhaps to put the text in alignment, in proper order. I don't know.
Yeah, that's kind of true. As we can kind of see, we kind of just align it to the center. So it just calculates the width of the page, and then it just puts it in the exact center, which is kind of cool because it's a heading, and usually headings are in the center. So that's the first thing you kind of catch. And something else that I think is usually a large part of most websites is the background color. And you can kind of just change this in the same way that you change the font size. But instead of changing the background for just the H1, we want to change the background for the entire page. And as we know, and I kind of talked about earlier, everything that we have on the web page is defined in the body. So I'm just going to directly change the color of the body so that, and for now, I'll just change it to purple, for example. And as we can see, the entire web page has shifted colors to purple. And another thing that I'll quickly go over is font size. I know all the headings come with a predefined font size. But if we say we want to make it even bigger for our page, we can use this feature called font size, and then we can specify a number, and the px just stands for pixels, and HTML requires that you have px because that's how it calculates the web page. So px, it just takes the width height of 80 pixels. But for example, say I remove it, it'll just be confused, and because it doesn't know what 80 means in reference to how many pixels, it just defaults to the normal setting. But that's just a little bit of background about HTML and how we might use it. Are there any questions about any of this?
I have a question, please. If you want to choose a specific font or font style, is there a code or something you can put there, or you just one particular kind of font?
There should be a thing. There's a feature called font family. I believe this is a proper syntax for it. Okay, maybe. But sometimes it also doesn't work on, because you have to download the font first or load it using, like, for example, there's this website called Google Fonts, and there's like a lot of different fonts, and you can kind of just say I want to use the first one that I have right here. You can import it into HTML by selecting, if you select the font, you can kind of see HTML code here. As I was kind of talking about, there's like links here. So first what you're gonna do is like connect the link to your web page and then specify the font family like here, as I was kind of doing earlier. We'll just, once we import it into our document, we'll change it. Sorry, so once we import it, what we'll do is we'll use the rules and the syntax that we were kind of learning about earlier and change the font family here. But I'm not sure that the import thing might work, or I'm not sure whether it will work or not in
It's working
WWDC.
now, right? The font is different.
It's all right. It's all right.
Oh yeah, I think it
you.
did work actually, yeah.
Yeah,
Because this heading is like a little bit different compared to this heading.
All right.
But
All right.
are there any other questions?
Yeah, once again, I'm Brian. It's actually not a question, it's a commendation because I've been so scared about, HTML and all of these codes, but hearing you talk about it makes it, it's kind of soothing to know that, I mean, it's not something to be scared about, It's something that can be done if one pays attention to it. So thank you very much.
Yeah, definitely. I think code at first can seem like very intimidating, and it seems like a lot at first, but every basic HTML web page starts with the same elements that I was kind of talking about. This is a very basic one, and next we'll show some of our projects, or at least like one or two. I know we don't have a lot of time, but for example, like last year, or as a 10th grader at IMSA, everyone's required to take a computer science class. And as a part of that class, everyone has to build their own website. And this is the website that I built. And this also started off with like the same basic elements of HTML. And as we can see, this is kind of just like a fake food cookie business. And there's like a menu. You can order cookies and select sizes and submit the form. And there's just different parts to the website. But and I can quickly, and cool thing about Google is that if you right click on any Google site, you can inspect the website, and inspecting it will allow you to see the code. For example, this is a code that I initially had for my website, and everything in green here are just comments. And we use comments as programmers because we just they don't actually serve any purpose in the actual code, but it makes it easier for someone else or like a teacher, for example, to understand your code and be able to understand what each line or what each section is doing. And here, this is just kind of some code that I used. For example, as we were kind of talking about, I used a list, and everything in the upper, like the tab is just like a list of links to the next site. And you can do this to any website. For example, if I go to like the Zoom website, which is the platform we're using to connect today, every website has the same HTML code. They're just a little bit more complicated. And as you can see, everything kind of just has that same format and style. But I hope you guys learned a little bit about HTML today. And please let me know if you have any questions.
So I hope you all enjoyed today's presentation. I know we all enjoyed teaching you just a little bit about computer science. For those of you, I see there's some schools in here with a computer lab. So there's several online tools that you can use to explore HTML. And I know one of the comments was that like it's very scary to start coding, and I had the same feelings when I started. So if you want to learn more, you can go to W3 Schools or code.org to get started with HTML. And also stay tuned for more collabs with us to learn more about CS, computer science, and other fields of engineering. Does anybody have any last questions before we end?
If not, thank you so much for all of you guys for joining, and we really hope that you guys enjoyed our presentation. I know we definitely enjoyed, as Alyssa was saying.
Thank you very much. Thank you so much, Imani. Thank you, Maya. Thank you, Samantha, Alisa, and Nora. I hope I pronounced it well. Okay. Yeah, Netra. We actually enjoyed it so much, and we wish it wasn't ending today, but we are hoping that you will come up maybe sometime in February to continue to teach us more on this. We are very, very grateful. We appreciate. Want to say thank you to some other schools, not just Community Secondary School Olanada, which is a school in the community area of River State. We also had a private school, which is Charlesdale Memorial School, and we also had Bereton Montessori School hooking up with us here. We had D&G Club, STEM Club hooking up with us, and we had some people from Zambia. We had someone also from Kenya, the school. So, okay, yes, I can see CSS Opopo is logged on. So, you've actually reached out to hundreds of kids and children that previously knew nothing about coding, even teachers. So we are very, very excited. We also want to say thank you to Professor Choma Place. And then we had collaboration with ACWEN. It was actually sponsored by ACWEN. ACWEN is the Association of Professional Women Engineers of Nigeria. And I also want to say thank you to IMSA, Illinois Maths and Science Academy in Aurora. Thank you so much. In fact, we're excited that we're speaking with you, like so many continents across the globe, and we're learning and we're gaining value. So I want to say thank you. Thank you so much.
Thank you.
Yeah, and I know someone else was asking about our next event, but we'll just we don't have an exact date as of yet, but we are aiming for the end of February, as we were talking about earlier. But once again, thank you so much for joining today, and we hope you enjoyed and learned something out of our session.
I think also if anybody wants to explore a specific topic or has questions about a specific topic, you can reach out to us and make sure that we talk about that topic if you have any
Mhm.
questions.
Of course, in our next
And-
session, probably, hopefully in February. Oh, sorry, but thank you for being so engaging and asking questions. We really look forward to seeing you once again.
Yeah, we really appreciate you guys listening to our presentation.
Thank you
And-
so much. Thank you so much.
I think she might have froze, but if anyone has any questions or would like to contact us in the future, I can put my email and then my phone number in the chat too. And then I can just forward that message to the rest of our team.
Our students want to say, they want to say thank you. There's so many of us there who can put on their camera.
Recording in progress.